I'm going to give you y equals negative 2x squared plus 6x minus 4. And I want the vertex, axis of symmetry, y-intercept, x-intercept, domain and range. All algebraically. So, if I want the vertex, the axis of symmetry, and the domain and range, I have to do what to that equation? Yeah. Convert it. Convert it to vertex form by completing the square. The plus blank minus blank thing. Right? I'm going to have to do that. For y-intercept, I should immediately think what? What should pop in my head?
0.
What is 0? To be on the y-axis, x has to be 0. To be on the x-axis, and then you're going to fill this in, and you're going to fill a 0 in for y, and then you're either going to factor or quadratic formula. Okay? So you have to complete the square first in order to get it the vertex, axis, symmetry, domain, and range. Y-intercept fill a 0 in for x, x-intercept fill a 0 in for y, and factor or quadratic formula. And go. First thing I want you to do is type it in your calculator, because it made you do everything algebraically. Go type this into your calculator into your y equals. Type into your calculator into your y equals. You're just typing it in, because mine won't work. Okay, did you type it into your calculator? And then you go zoom 6. Gets you to your standard window. Zoom, and then 6. So if you were ever stuck and you didn't know what to put your window at, you could always do zoom 6 and then work from there, correct? Now, can you see it on there? Yes. Now, is this a minimum or a maximum? It's a maximum. Even if we didn't look at our calculator, we should know it's a maximum. How should we know it's a maximum? Because there's a negative leading coefficient, correct? So we know it's concave down. So we know it's a maximum, we know it's concave down. Now, let's try and find the maximum. So we're going to check, because that's our vertex. Remember, there's no word for vertex in that calculation, but there is max or min, which is the vertex. So you go second, trace, maximum. Everyone's finding it. Even if you found it already, you're finding it again. Second trace, maximum. And then you need to be on the left side of the maximum when it says left bound, enter. Then on the right side of the maximum when it says right bound, enter. And then enter again. Colton, what is wrong? You are dazed and there's no calculator. He was like singing. He was mouthing the words of whatever song he said. Yeah, I was a little crazy. I was genuinely concerned. Okay, so did we get that? Did everyone get the minimum or the maximum? In this case, maximum. And the maximum is your vertex, so it should match whatever vertex you got, correct? So that's how you can check if it's vertex form, you can check if you got it right. Now, next thing I want you to do, x-intercepts. So you're going to go second trace, which one to get x-intercept? 0. So you have something that looks, I don't know, something-ish. It's not like that at all, but let's pretend it is. Now, yours is more like that, but whatever. Anyways, we want to find the first one. We agree? We want to find the first x-intercept? Yes, no, maybe so?
Maybe.
Oh, wait. I haven't. So you're going to go second trace, 0. Now, why are we doing zeros? What is this?
Synonym for x-intercept.
Because it's a synonym. That is a good word.
Thank you.
That's at least a toony word. If you rate them with money, that was about a toony. That's pretty good. Okay, so I got aggressively large on where this is going. Let's go this way. Oops. So it looks like this. Now, it's hard to do left bound, right bound when it's that close to the x-axis. We agree? So what would be better is if I possibly got rid of all of this extra area here, and then it would zoom me in, and I could probably figure it out better, correct? So I should make my... No, it's not. No, it's not. All right, so what we need to... You probably put +4 or something. Negative 2x squared plus 6x minus 4. Found the problem. All right, good talk. So we want to make our, hey,
I'm recording calculator.
that's not what I was talking about. The calculator comment was the issue. Oh my gosh. Okay, so y max, go to your y maximum. And you want to make your y maximum smaller, so maybe make it be a 2. You have a whole bunch of extra room up there.
Wait.
So maybe I could shrink the y minimum too. We may go to the y minimum and make it be a negative 2. I really wish I could pull my calculator.
No.
Now can I see a little bit closer what I'm dealing with here? It makes that x-intercept pop a little higher. So I made my y max 2 and my y minimum negative 2. Y max 2 and my y minimum negative 2. So I zoomed in basically was what I did, right? We agree? So now we have something like this in front of our faces. So it's actually the exact same graph, it's just more zoomed in, so I can see the bigger space, correct? Now, I want to find the 0, the x-intercept. So this part here. So I want to find this. So I draw an imaginary dashed line through it to help me out better with my lefts and my rights. Right, Sam? Yeah, cool. Okay, so that didn't mean you should pick your
I
phone
was
up.
checking the time.
He felt obligated. Okay.
My wrist was down here, my phone was down here.
Clock there, and
That one is not working. That one says it's 6:23.
I don't feel like doing math, but I don't know how to pop there. There's math.
That's you're gonna have to do a lot of math. Okay, anyways.
Shh.
Nick, stop, please. All right. So we're going to look at this one. We want to do the left bound of that x-intercept. So which part is the below or the above left? What part is on the left of that x? Here. What part's on the right? Here. Don't go past that. Just go on the left and the right. So you're going to go second trace, number 2, and you'd be on the left bound of it. Now, if you're someone, I'm going to tell you this because it's extremely helpful. I really wish my calculator was on my board. Look at your actual calculator in front of your face. Look at the bottom. The bottom tells you where the bullet is, right? Where it's blinking. So if you don't have the blinking on your calculator and you're like, I don't know where it is, and then you just viciously press left and right and hope to goodness it shows up on your graph, that is not the best way. It literally tells you where that blinking dot is. So if the blinking dot is at like negative 1,000, and 2 or something, then we need to arrow right to get ourselves to come back up, correct? Or arrow up or down, right? So the blink, that tells you where it's blinking, right? So I need to be on the left side of it, so below it, and then above it, enter, and what do you get? What's your first x-intercept at? See right in front of your face. Yeah, it's at what? 1 and 0. So this one's at 1, 0. How do I know that? Because it says 1, 0. See what calculator told me. Isn't it crazy? If you're not following along, it's going to be rough in either 30-1 or 30-2 because we make use of calculator to find a lot of x-intercepts. Okay, now we need to find the other one. So we go second, trace, 2. If I repeat the exact same steps, I'm going to continuously find the same exact x-intercept. Do I want to find the same exact one? No, I want to find this one. So now I need to be on the left of it. The left of it is up here and the right of it is down here. If it says error, it's because you picked the wrong left and the wrong right. And by wrong left and wrong right, I meant you picked right for left and left for right. Okay? So hit enter and then below enter and then enter when it says yes. And what should we get for our second one? 2, 0. So we know that that's what it is using our calculator. We know our vertex was what again? I don't remember. You should know if it's in front of your face. 1.5 and 0.5. Or 3/2 and a half. We agree? So from our calculator, we know all that stuff, which is lovely. However, I told you to do it all algebraically. So if this was just how you gave me the answers, you'd get no marks because you did no algebraically. You did graphically and therefore didn't listen. Okay? So if it says algebraically, you need to do algebra. Now, let's actually do the vertex algebraically. So if I want vertex algebraically, I'm going to have to convert that to vertex form. So I'm going to have y equals, the negative 2 comes out of my first two terms. So I get square bracket, round bracket, x squared, negative, or 6 divided by negative 2 is negative 3, x plus blank, minus blank, square bracket, and then minus the 4 at the back. Now how do I get the blank? I actually have to do b divided by 2 squared, correct? Which is not going to be pretty. I get that. You'll be okay. So we're going to go negative 3 divided by 2 squared, which is 9 over 4. Now you can put the decimals if and only if the decimals terminate. If the decimals repeat, you have to put the fraction because you're going to try and round. Are we allowed to round ever? Not until the very last step, right? So we can't ever put a rounder. But if I go 9 divided by 4 in my calculator, it gives me 2.25. Can I write 2.25? Sure. It terminates. It ends. I'm fine with that. I didn't round at any point in time, right? I'm just writing what I have. So this is the same as 2.25. So I'm going to get a 2.25 here and a 2.25 here. So now I get y equals negative 2, round bracket. Now what multiplies can be 2.25 and adds can be negative 3? I have no idea. But if I look one back, which actually happens to be the bracket, it's negative 1.5. So I get x minus 1.5 squared. And the reason why you have the square bracket is so that you remember to distribute that in. So negative 2 times negative 2.25 is positive 4.5 minus 4. And so I get y equals negative 2 x minus 1.5 squared plus 0.5. So what's my vertex? My vertex is the same as, or opposite of this. So vertex is 1.5. And same as the back, 0.5. And the reason why it is that is your normal quadratic starts at 0, 0. Correct? And it's concave up. The parent function of y equals x squared is at 0, 0 and concave up. We agree? Well, this one has been moved 1.5 to the right, hence 1.5, and 0.5 up. So it moved it right to that vertex. So that's why it's always the opposite. Now, we need the vertex. That's that. What's the axis of symmetry? The axis of symmetry is the line that cuts the graph in half vertically. What is it? What x value cuts this graph in half? 1.5. So we have to write x equals 1.5. Your vertex x is the x that cuts the graph in half. So your axis of symmetry is x equals 1.5. The domain of every quadratic, whether it's concave up or concave down, is x such that x is an element of the reals. And we're going to go over interval notation starting tomorrow. This is all set. We've done set all year. And my range is y such that y is less than or equal to the y of my vertex. So 0.5 y-er. Because there's no graph above that. That's as high as it goes. My y-intercept is really easy, and the form that you want your y-intercept... What is going? I must have two of those going. I do. That's weird. Okay. When you want to do algebraically for y-intercept or x-intercept, you always use not the vertex form. So we would use the original. So we have y equals negative 2x squared plus 6x minus 4. If I say y-intercept, you should immediately scream out of your mouth x equals 0. That should be instantaneous. If it is, you will do way better in math, even next year. So we fill x equals 0, we get y equals negative 2, 0 squared plus 6 times 0 minus 4. So it's at y equals -4, which we know if it's in general or in standard form here, that our y-intercept is just a back number. We know that, right? But why is it? It's because all the x's actually become zeros. Now that isn't my y-intercept. My y-intercept isn't -4. My y-intercept is a coordinate. So don't forget to go 0 and -4. Now my x-intercept is a coordinate as well. X-intercept y equals 0, and we always want to use standard form as well. So we're going to go 0 equals -2x squared plus 6x minus 4. Now I know the answers here are nice whole numbers for my x-intercepts. It's 1 and 2. We agree? When those are nice whole numbers, not crazy decimals that are like 5.67982, I know I can factor it. So if they're even if they're normal decimals like 1.5 or 3/4, I can factor it. It's when they're crazy decimals that I know I'm going to have to go with the quadratic formula. Okay? So I'm going to factor it. If you use quadratic formula, you'll still get the same answers. So when I go to factor this, I'm going to say what times what equals +8, because I multiply the front and the back, and what plus what equals 6. And so I'm going to get 4 and 2. So I'm going to get 0 equals -2x squared plus 2x plus 4x minus 4. If you're someone who still can't factor, there's no better time than the present to admit that. Come get help, okay? You're going to need it for both -1 and -2 next year. So I take a -2x out, I'm left with x minus 1. Take out a +4, I'm left with x minus 1. So I get -2x plus 4 and x minus 1. I could have actually taken a -2 completely out of this and then factored it. So if you didn't spot that, you could use the whole thing. And then that's all grade 10. I haven't done anything extra yet. That's all grade 10. Grade 11 is to just take each of those and set it equal to 0. That was the extra part of the lesson. So we go -2x plus 4 equals 0. X minus 1 equals 0. -2x equals -4. 5 by -2, x equals 2. And then this one, add 1, x equals 1. Okay, I'm going to show you how you can use this in trig. We're going to do a trig one.
Is this grade?
12. Yeah. But you can do it. It's actually nothing crazier than what you did before. Okay, so we're going to write this one down. Okay. Sine squared x minus 3 sine x minus 4 equals 0. It might not be, I don't know. There's one over there, but it doesn't have a cover. You just have to put it over the garbage can. So, this question looks way more complicated than it actually is. We're going to go 0 degrees is less than or equal to x is less than or equal to 360. So they would give you a solution where we have to solve. Now we've solved these before where we had like 2x or 2 sine x minus 1 equals 0, and we get sine x by itself, and so we get sine x equals a half. We go to our unit circle and find out where y is a half, put down 2 degrees, right? That's what we did. So it's the same thing, we just have a much more complicated situation right now. But we can make it quite easy by just using grade 11. And I'm not joking, grade 11 and grade 10 is used every single day in 30-1 and 30-2, especially 30-1. Every single question is finished using grade 10 and 11 math. It's very important. Quadratics is used a ton. So here's an example of where it is. So the best thing we can do is get rid of the sign part, right? Because the sign part is the overwhelming part, is it not? Yeah. So we'll just replace it with a variable. So I'm going to say let m equal sine x. So what do I get? I get m squared minus 3m minus 4 equals 0. Now we just factor. Now we're just in grade 11 again, aren't we? But if you can't do grade 11 stuff, can you do this question? No. majority of this question is grade 11, and you'll see. So, okay, we have this. Now what do? We factor it. What multiplies to me -4 adds to give me -3. -4 and 1. I have a 1 in front, so I don't need to do decomp. So I get m minus 4, m plus 1. And what did we do in grade 11 when we got to this point? Set each equal to 0. So we get m minus 4 equals 0, m plus 1 equals 0, m equals 4, m equals -1. And then people box it and move on because we're so used to grade 11. But we haven't done anything with trig yet, have we? So once we do this is all grade 11, we just put the trig back in. So now we have sine x equals 4, sine x equals -1. This is still grade 11. There's actually only step of this in grade 12 is to say, hey, replace that with an m. That's the only grade 12 step. Now, sine x equals 4. What you don't know yet, and you'll learn more in grade 12, is that a sine graph actually looks like this. And they'll just keep going. It looks like this. It maxes out at 1 and it mins out at -1, which we know that's the case because your unit circle maxes out at 1 and mins out at -1. We agree? So where does sine x ever equal 4? Never. So actually with sine and cos, if you ever get this equaling to greater than 1 or equaling to less than 1, this would be no solution. There is no places where this can happen. So actually people freak out when it is like sine x equals 2 or sine x equals -2. I'm like, don't freak out. Be excited. That's no solution. There's no work. Yay, great. I learned to be excited at those ones. Now, sine x equals -1. You guys are good at this. Go to your unit circle. Go find out where y equals -1. This is totally a grade 12 question. You can do it. Sine x equals -1 where y equals -1, which is down here. Which is 270. Now, how we would actually write the solution down is we go to our variable is x, and we'd say x equals 270. Now, how do they amp it up? How do they make it a bit harder? So instead of it being from 0 to 360, they might restrict your domain to something different. They might go -180. So if it was 0 to 360, this would be the answer. But what happens if I would go -180 is less than or equal to x is less than or equal to 0? I would do nothing different. I would find everything exactly the same. And then I would just find its coterminal that fits. 270 doesn't fit, correct? But how can we get a coterminal that's negative of it? What did we do? How can you get something? So here we have this. We have 270. We know that if we go backwards, we get something positive. We get like a negative angle. Negative angles go clockwise. Positive angles go counterclockwise. We did that, right? What would we have to do in order to circle and come right back? How many degrees is that? How many degrees is a circle? 360. So if I actually subtract 360 from this, I just go 270 minus 360. I'm going to get -90, am I not? Does -90 land there? We've drawn angles with negatives. We've totally drawn angles with negatives. We just go clockwise. This is 90, is it not? -90. It lands on the exact same arm. It's called coterminal. That's what we'll just deal with next year. So the only thing we'll do is we'll find it all from 0 to 360 just like normal, and then we'll subtract 360 or add 360 to make it land in the domain that they give us, because grade 11 domain is always 0 to 360. Right? Nothing crazy. I'm going to get you to do another one, but I'm going to get you to do it from 0 to 360. We're not changing the domain. I just wanted to show you that we can change the domain, and it's not a big, hairy deal. People freak out at that point. It's not that bad. Okay? But you also been taught coterminals at that point. Okay, so I want you guys to try this one. 2 cos squared theta. I'll call it an x so you don't freak out just for this. 2 cos squared x minus 3 cos x plus 1 equals 0 from 0 to 360.
Is cos the same where it's like...
Yeah, let m equal cos. Yeah.
No, where it's like -1.
Yeah. Because cos is falling in the unit circle too, it's just the x's. So it still maxes out at +1 and -1. Tans are a totally different story. But we're not dealing with those. Okay, so we're going to go let m equal cos x. Now remember, even if it was, the way they could give it to you is 2 cos squared x minus 3 sine x, or minus 3 cos x equals -1. And like quadratics in grade 11, you know the moment you have a squared, you can move everything to one side, set equal to 0. That needs to be also in your brain. X-intercept, y equals 0. Y-intercept, x equals 0. You have a squared, get it equal to 0. These all need to be things that just pop in your head, so you're not trying to think what you need to do. Because most of you can do stuff once you start it, but you'll sit there and stare at it for 20-some years being like, I don't know what I'm supposed to do first. Okay? We want to be past that. We want to get stuck in the grade 12 stuff, not the grade 11. We don't want to get stuck in anything. But if we're going to get stuck, we want it to be in the subject we're in. You know what I'm saying. All right. So we're going to get 2m squared minus 3m plus 1 equals 0. What multiplies to give me 2 and adds to give me -3. -2 and -1. So we get 2m squared minus 2m minus 1m plus 1 equals 0. Then I group, put a plus sign in between them. I can take out a 2m and left with m minus 1. Take out a minus 1, m minus 1. So I get 2m minus 1, m minus 1 equals 0. Still all grade 11. Everything I've done. I don't want to see it. Put it down. Leave the poor soul alone. Okay. So we get 2m minus 1 equals 0. M minus 1 equals 0. This one's going to be m equals 1/2. This one's going to be m equals 1. So do both of them actually work? So do? I can't even speak. So do both of them actually work? Yes. So we have cos x equals 1/2. And cos x equals 1. Now, why do people suck at these questions? Do they suck at them because of the trig? No, they suck at them because they can't factor. That's the sad part. So it all leads back to grade 10. It all leads back to grade 10. So we don't want to be that person who doesn't know how to factor, proving once again that there's no better time to admit you suck at factoring than today.
I don't suck at factoring.
Okay, that's all right. I'm fine with that. That's okay. You can hate it. So we need cos x. We need cos x equals 1/2. So we need to know where x equals 1/2. Shh. X equals positive 1/2 in these two quadrants, which is at 60 and 300. And then cos x equals 1 here. Now, you have to actually pay close attention to what I gave you for a domain. So I gave you 0. It's equal to 0 and it's equal to 360, so I would actually get two solutions, correct? But sometimes they won't make it equal to 0 or 360, then I would actually get no solutions for that one. Or they maybe make it equal to 0 but not 360, then 0 would be the solution. So you have to really watch what these equal to signs give you, okay? Which is both of them in this case. So we have 0 and 360. So you can't just leave it like this. You have to go, hey, what was the equation's actual variable? Oh, the variable was x. So I'm finding out what x equals. Because this question is going to say solve. And remember I told you whenever it says solve, it literally wants to know what a variable equals. So in the end, when it says solve, I need variable equals number. Doesn't matter if it's a radical, an absolute, a quadratic, next year, a log, an exponential, a trig. It doesn't matter. If it says solve, in the end you need variable equals number boxed. Correct? Okay. So we're going to go x equals 0, 60. So not listed in order. It's not the end of the world. I just like listing them in order. 300 and 360. Now, grab your calculators. Learning something new. Really wish my calculator didn't tell me that it was ended now and I have no more calculator left. That's what it literally just told me. So I want you to type into your calculator the original equation. 2 cos squared x. Now, the moment you press cos, guys, the moment you press cos, a bracket opens up. So can you put a squared in there? No, a bracket opened up. So the only way you can actually type that into your calculator is you're going to go 2, and then cos, a bracket opens up, you're going to put an x, but I have to square it, so you actually have to have a bracket around it and square it. Because cos squared x is just 2 coses squared, and that's the only way you can type it into your calculator. So you're going to have to go 2, open bracket, cos, x, close bracket squared, minus 3 cos x, plus 1. So type that into your y equals, please. Now, the moment I press the cos, the sine, and the tan button, I have to slap my hand and be like, what mode do I need to be in? Now, in grade 11, you can thank the Lord that you only have to be in degrees. But next year, it will be degrees and radians if you're in 30-1, or only radians, actually, if you're in 30-2. You won't even touch degrees ever again if you're in -2. So, make sure you are in degree mode. Does everyone have it in degree mode?
Word.
Now, go to your calculator and you're going to press zoom, but instead of 6, which would not be helpful to this window, you're going to go zoom number 7.
This is cool. Oh, I must be cool.
Yeah, go zoom number 7. It gives you a graph. Boom, 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 right? Now, my domain needs to be between 0 and 360. So can you press the window, guys? Press window. What's your x minimum on your window right now? No, your x. Are you in, okay, check your mode. If it's 0.15 something, then you're in radian mode and not degree and inverse. Go to mode and press degree, please.
Oh, that's why.
So what's your x minimum at when you press zoom trig? You went zoom 7. What does your x min say on the window right now? You're reading what?
Yeah, I'm getting -3.
Yeah, it's -352 something. Okay, did you type that in with x's? Are you in degree mode?
Something is wrong before it needs to cross.
Oh, good easy.
Oh, that's why. I was like,
Oh, it's -3.
When?
what did you do?
Just wrote it in, and everyone should know.
It is.
Way more.
No.
In your ear.
Okay, when you press window, please go to your window now and make your domain be between 0 and 360. So your x min needs to be 0 and your x max needs to be 360. And why would I do that? Well, look what this domain is. Between 0 and 360. Bless you. So your x minimum is 0 and your x maximum is 360. Then press graph. How many times does it cross the x-axis?
I have no idea. This didn't even work. I just nothing there.
Why doesn't even, I don't know. Mine just disappeared.
Why is mine not?
Well, I mean, on mine?
Now it looks like it crosses twice, but guys, what are 2 of your solutions?
0.
0 and 360. So if you actually want to see that crossing, you might need to make your x max and x min a little bit bigger, a little bit smaller to see that it actually crosses there, right? Because we limited it to 0 and 360, we won't be able to see that as much. Now we could just go second trace 0, left bound, right bound, enter, left bound, right bound, enter, left bound, right bound, enter, left bound, right bound, enter. And we get all 4 answers, which are 0, 60, 300, and 360. So you could just find the X-intercepts. That's all we did. We just found the X-intercepts. So you just have to go second trace 2. Try and find one of them. Try and find 60. Go second trace 0s. Number 2.
Oh, there.
Yeah.
Why is my exit like the 7?
So if you go second trace number 2, 0, and you left bound, right bound on one of them, you'll get 60. or 300. Yeah. Just finding your x-intercepts. And we solve this all. Yeah. So every time it says solve, we need variable equals number. That's what we need.
How did you get the almost? I got.
Well, I got them from solving algebra.
Yeah, I got 0
Oh. It can't equal larger than 2, or larger than 1, or less than 2.
That's one.
Cosec's like half. You know that. And
That's
2
not.
solutions.
What was the thing to go for?
Okay. So that's just a glimpse into next year, what you can see, what you can do. But it just shows you that, honestly, the grade 12 stuff, a lot of the time people are not stuck on grade 12 material, they're stuck on the previous material. I'm like, you guys rock at your grade 12, your 10 and 11 is abysmal. And that's just the saddest thing. So you guys weren't really all that gapped. We've filled the gaps for 10, and you don't want any gaps in 11, we didn't miss any school, right? So in grade 12, you should be good to go. You should know your 10 and 11. You can reduce a radical. You can reduce root 24 and say it's 2 root 6. Some people this year couldn't do that because they missed grade 10. Grade 10 was COVID year. Okay, so I feel like you're in a better state. Now, let's go through this. Y equals negative 2, x plus 6 squared minus 4. I told you we were going to talk about stretches, reflections, translations. On the test, I only forced you to have stretches and translations. I was being nice. And I told you, does the wording matter? Yeah, the wording completely matters. If you don't word it the way we word it, you don't get the marks. Honestly, I've sat and marked diplomas. It doesn't work. If you just choose to write a quarter of it, you're like, they'll figure it out. Yeah, they'll figure it out and give you nothing. That's what they will figure out. It will be a sad day. And they'll be like, that teacher didn't teach her stuff. Or they'll be like, this kid didn't listen to the teacher. Because that's what I think when I read it. I'm like, didn't trust the teacher when the teacher said they would lose marks. So, the 2 in front causes a vertical stretch. Okay? It's a vertical stretch, and it's never negative because the negative doesn't actually make the graph stretch anymore or any less. The negative causes these graphs to be concave up to concave down, correct? That's all the negative does. It makes a graph that's pointing up to be pointing down. So it actually reflects in what axis? If it's up here, and now it's down here. If it's down here, it's now up here. What axis am I reflecting over? The x-axis. So this is a reflection. I'm just going to write this now anyways. It's a reflection in the x-axis. And it's not hard to remember what axis, because all of these are going to be x-axis, but also positives concave up, negatives concave down. If you just do this with your hand, you see what axis I'm flipping over, right? Concave up, concave down, concave up, concave down. It's the x-axis that's in the middle of that. Okay, this is a vertical stretch. What do we say? We know this one. By a factor of 2 about the x-axis. And I have to do it in stretch, reflect, translate order because stretches and reflects multiply and translations add and subtract. So it's just because of order of operations. Now, what does the x plus 6 do? Horizontal translation. Six units what? Left, yeah. It's always opposite, right? Because we have that minus and minus sign in there. So it's always opposite. And then we have a vertical translation. Four units what? Down. And we'll keep doing a few of those a day. Now I'm going to give you a couple radicals to do. So I want you to simplify. Okay, there's 2 simplifying for division. I'm going to give you this one. Yep. Yep. And then I'm going to give you
This is
What?
So, remember when we have a binomial denominator, it's called rationalizing the denominator. Rationalizing the denominator means getting rid of the radicals, correct? And we need this for next year. The third one, we need to be able to rationalize the denominator, so we'll be using it in trig again. Now, we need to get those radicals to go away. So if we have a binomial denominator, what do we need to multiply by? Do you remember? The conjugate. And the conjugate is literally the exact same terms, but what? Is opposite sign. And the reason why that you do that is using the exact same terms opposite sign of the denominator, which is the conjugate, you actually get rid of the middle 2 terms. And then you get rid of the radicals. So when it's a binomial denominator, we are going to multiply by 4 root 3 plus 3 root 5, the conjugate. 4 root 3 plus 3 root 5, and you're going to have to FOIL, or distribute using first, outer, inner, last. What about this one? It's a monomial denominator. My issue is the root 3. I need that root 3 to be not a root 3. I need that root 3 to, I need the root to just go whoop, away. Yeah. You could times it by 5 root 3, and it'll get the root 3 to go away, but you're going to end up having to GCF at the end and reduce it. You could just do root 3 in this case, because if I go 5 root 3 and I multiply it by root 3, it's just 5 times 1, so 5, and root 3 times root 3 is just 3, because when you multiply 2 roots that are the same, 2 radicals that are the same, you get the answer, right? So could I do 5 root 3? Sure. But then I'm going to multiply these all by 5, and then I'm going to have to take a 5 back out of all of them. So it just makes more work, but you could totally do that. But if I look here and I say, remember, we don't want to do stuff by memorization, we want to do stuff by understanding. So if I have 5 root 3 and I need this root to go away, if I multiply by root 3, the root goes away. Do I need to do anything else? No, I'm making the problem go away, right? So multiply by root 3. And then you distribute. So you try these 2. So we have to FOIL the top and FOIL the bottom, and hopefully the bottom comes out with no radicals. If the bottom doesn't come out with no radicals, you messed up, because that is why we're doing what we're doing. Instead of the denominator to not have any radicals, to rationalize. Okay? So we go 3 root 2 times 4 root 3 is 12 root 6. And then we go 3 root 2 times 3 root 5 is 9 root 10. Then we do 2 root 3 times 4 root 3 is 8 times 3, which is 24. And then 2 root 3 times 3 root 5 is 6 root 15. All over 4 root 3 times 4 root 3 is 16, and root 3 times root 3 is 3. So 16 times 3 is 48. And then I hope the O and the I of FOIL cancel. If the O and the I of FOIL don't cancel, you did not multiply by the conjugate, or you didn't screw it up in your multiply, right? But the O and the I should cancel. So 4 root 3 times 3 root 5 is 12 root 15, and I better get a negative 12 root 15, or I did not multiply by what I should have. Negative 3 root 5 times 4 root 3 is negative 12 root 15. And they cancel, so I know I did good. I done well. Okay? Teaching English 30 next year. Not a chance. Negative 3 times 3 is negative 9 times 5 is negative 45. So we're going to get 12 root 6 plus 9 root 10 plus 24 plus 6 root 15. And if the roots can reduce, we do, but they can't. And then over 3. Can we take anything out of every single term? We could actually take a 3 out of every single term. So this becomes a 4, this becomes a 3, this becomes an 8, this becomes a 2, this becomes a 1. Do I need to write the 1 if the 1's in the denominator? No. Do I need to write the 1 if the 1 is in the numerator? Yes. So I get 4 root 6 plus 3 root 10 plus 8 plus 2 root 15. Okay, the next one, I do 6 root 2 times root 3 is 6 root 6. You see equal signs running down the left side. I really hope that if anything, you've left this room putting equal signs on the left side when it's a simplified question. Please. 6 root 2 times root 3 is 6 root 6. 4 root 3 times root 3 is 4 times 3, which is 12. Over 15 root 3 times root 3 is, or sorry, 5 root 3 times root 3, I get the answer, is 5 times 3, which is 15. Can I take something out of all of them? Yes, I can take out a 3.
Yeah.
Okay, last question, what I want you to do. I want this in standard form, and I want the y-intercept.
Standard form.
So, we write it out twice. We get y equals negative 2, x plus 4, x plus 4 minus 7. Then we get y equals negative 2, x squared plus 4x plus 4x is plus 8x, plus 16 minus 7. Then we distribute the negative 2 in. So we get negative 2x squared. Guys, it's really annoying watching a podcast when you guys do that. So if you could stop, that would be fantastic. Negative 16x minus 32 minus 7. So y equals negative 2x squared minus 16x minus 35. What's my y-intercept? What's my y-intercept? What happened? Where's an oopsie? Why? Where is it sus?
7 plus.
Oh, it's 39, eh? Yeah, it is sus. How did I get 35?
I think that's
She thought it
Probably
was
Do you want to know why I get negative 39? Because people talk the entire time I'm teaching, and my brain's going, just ignore them. Just ignore them. Keep going.
Blame
Everybody just sit out there and laugh.
You guys are all sus.
Rather take the
Suspicious.
47-10.
Suspicious. 20? I can't even. That's a 47.
I said 47.
You said 27.
I did not say
Let's turn back